In this lesson, we're going to take a look at graphing standard form equations. Now, what we've been introduced to so far and what we've been working with have been equations that look like this. Y equal mx plus b. Okay, slope is m, the y-intercept is the b. Y equals slope times x plus b. And technically what this is called, this is your slope-intercept form. It's the name given to it. Why? Because you have your slope and you have your intercept easily identifiable here. Another form that you can often come across when dealing with linear equations, things that make straight lines, is what's known as standard form. Standard form usually is this: a number multiplied to your x plus another number multiplied to your y equaling a third number. Okay? Similar parts. I still have my x, I still have my x. I still have my y, I still have my y. What's different though is the number that's in front, the coefficient that's in front of the x, isn't necessarily your slope anymore. And the plane number over here is not necessarily your intercept anymore. This is your standard form. Now this does have its own purposes. This does make a lot of other mathematical situations very easy because of how it's set up. We'll talk more about that at a later point. So let's take a look at this situation. I have my standard equation. It's a number times x plus a number times y equals a constant or a plane number. So this, what we would usually do, if your goal was to graph this, what we would usually do is we would solve this for y. Now, we did that to get it to go back to slope-intercept form. So if I would solve this real quick, I'm going to bypass the algebra steps. This would look something like y equals negative 3 over 2x plus 2. That's what this would convert into if we solved for y and went through our algebra solving steps. Now, the reason we did this was because we learned how to graph slope-intercept form. And that's what this now is. Here's my slope, here's my y-intercept. And if we would graph this, we would start at the y-intercept, which is 2. My slope tells me to go 3 down, 2 right. 1, 2, 3, 2 right. 1, 2, 3, 2 right. And I would get a line something that looks like this. In this lesson, you're going to get equations that are in standard form. Now, we could go through the steps of solving for y and then graphing it. But I want to show you a different way, a faster way, where I can leave this guy go, leave him in his form, use some information that I know, do a little calculating, and I'll still be able to graph it. So here's what we're going to do. We're going to use the concept of an x-intercept and a y-intercept. Now, y-intercept should sound familiar because that's where the line crosses the y-axis. An x-intercept does the exact same thing, except it crosses the x-axis. So here's what we're going to do. Here was my equation, 3x plus 2y equals 6. What we're going to do is work to find the x-intercept and the y-intercept. Now, if it is the y-intercept, by the way, I'm going to put an ordered pair here. I'm going to leave it blank for now. If it's on the y-intercept, where it's going to locate is the y number. Remember, my ordered pairs is an x and a y. So this is what we're trying to find. What is the x location on the y-intercept? What number? How far is the y-axis, right or left? Hopefully you say the value of x on this line is 0. My slope, my y-intercept has an x value of 0, which means I don't move side to side. All I do is go up and down, which is my y value. Okay, now if that can sink in a little bit, let's go and take a look at what the x-intercept would be. Remember, this is my x value, this is my y. Okay, in a y-intercept, I wanted to know what the y value was. So in an x-intercept, which value do I want to find? Hopefully you say x. That's what I'm trying to find. In the y-intercept, the x value was 0 because my y-intercept does not move off of this line. All it does is go straight up and down. So what is the value of the y on the x? Well, the y should not move up, should not move down. All it wants to do is move front to back. So hopefully you can see that if this was a 0, this will also be a 0. If that doesn't sink in right now, that's okay. Just know that when we have a standard form, this is what you want to start with. X, y, put 2 ordered pairs, and put your zeros towards the inside. As you go through this, hopefully it'll make a little more sense of why this is a 0 and why this is. So here's how we're going to work. I'm going to start with the x-intercept. The y value is worth nothing. So if I would take this value, 0, and substitute it in for y, you would now have 2 times 0. And how much is 2 times 0? It's worth nothing. So in essence, when we find the x-intercept where the y is worth 0, this term, this item, disappears. So now my equation says 3x equals 6. So watch what I did. I'm doing the x-intercept. So the y was 0, so I'm going to cover up the y term. Now, can we solve this very simply? 3x equals 6. If 3x equals 6, what does x equal? Hopefully you say 2. Let's go to the y-intercept. The x value is 0, so we would take this 0 and plug him in here, and you would have 3 times 0, which we know is nothing. So for the y-intercept, x being 0, I'm going to cover up x. Now I have an equation 2y equals 6. If 2 times y equals 6, what does y equal? Hopefully you can say that it is worth 3. Now just a quick note, not all times do these numbers go opposite. This is more coincidence than it is, oh, well just take those numbers and reverse them. That's not always how it works. So again, notice, here's my equation. I found 2 ordered pairs. I did very little calculation. All I have to do now is graph these 2 ordered pairs. So where is the point? 2, 0. 2, 0. 2 to the right, 0 up and down, put a point. That point's done. Where is 0, 3? 0, 3. There's my second point. And that one's done. Now we know that the minimum it takes to draw a line is 2 points. Once you have 2 points, all you have to do is connect. There's my line. And if you look back earlier in this lesson, the one I sketched earlier would look very similar. So this is taking standard form, finding my intercepts. Where does it cross the x-axis? Where does it cross the y-axis? Finding those 2 points by covering up one term at a time and doing a little solving in my head. Putting the 2 points on my axes and connecting. Let's take a look at one more. Second example, -6 times x plus 4 times y equals negative 12. Is it standard form? Do I have something times x? Do I have something times y? Do I have a number by itself? The answer is yes, this is standard form. So again, we're going to work for our x and our y intercept. I need an ordered pair here, I need an ordered pair here. If you do this enough, you'll get used to where the zeros go. Okay? Again, in the y, I'm looking for the y value, so that means the other one needs to be a 0. In the x, I'm looking for the x value, that means the other value needs to be 0. If you want to think about it, you can think about this as a pair of glasses. The glasses are in the middle, and the lines are on the outside. One suggestion. Okay, so here's my x, here's my y, here's my x, here's my y. So I'm ready. I need to find, let's start with the x this time. If the y is worth 0, so I'm going to cover up the y. Now my equation says negative 6x equals negative 12. So if negative 6 times x equals negative 12, what must x be? Hopefully you say x is 2. Now let's work for the y. X is 0, so I cover up the x term. 4 times y equals negative 12. So 4 times what is negative 12, or y equals what? Hopefully you say negative 3. I found my intercepts. Let's graph my intercepts. 2, 0. 2, 0. Check. 0, negative 3. 0, negative 3. Check. I found out what my x-intercept is, my y-intercept. I drew my dots. All I got to do is connect my dots. And there's my line. So what again this is a different way. Instead of having to solve this equation for y and get it to slope-intercept form, it's just using what we know with standard form, making 2 ordered pairs, graphing them, and making my line that way.